Okay, so today we're going to talk about linear functions. You probably covered linear functions in Algebra 1 and in geometry last year when you probably did slope, when you're talking about parallel and perpendicular lines. So this is two forms of a linear equation or a linear function. The first one is called slope-intercept form, and the second one is point-slope. We'll use point-slope probably more in section 2.4. Today we're going to focus on more of the slope-intercept form. Now, in your textbook, remember we're also talking about function notation. So in your textbook, you might see also f of x is equal to ax plus b. This is the same thing as slope-intercept form, where a is just some constant. So just like you guys asked me about the PSAT, the constant is your slope here, okay? And when we talk about section 4 on Monday, we're going to talk about parallel and perpendicular lines. And when we have parallel lines, when the slopes are the same, we're going to have a no solution. So this is the function notation of slope-intercept form. Remember, the number in front of x is going to be our slope. And this b is our beginning point when we graph, and it's going to be on the y-axis, so it's our y-intercept. The domain always for any linear function or linear equation is always going to be all real numbers. So the domain for any linear function is always all real numbers. Same for the range. So whenever you graph a line, then it's always going to be all real numbers for both domain and range. This is the point-slope form of a linear equation, where if they're going to give us an ordered pair and the slope, we would just replace these three numbers. This is another form of a linear equation. It's standard form, where a, b, and c are just going to be integers, so we cannot have any fractions. So no fractions. So if after we put something into standard form, rearranging it, if there's any fractions, you would multiply everything by the denominator to clear those fractions. The other stipulation here is a has to be positive. B and C can be negative. So we're going to talk about graphing. So if you're given a function or an equation in slope-intercept form, this is one technique that you can use to graph the line. Now, probably in Algebra 1, maybe your teacher made you make a function table, plug in different values of x, and do it the long way. However, if you're given an equation in this form, y equals mx plus b, and again, remember yesterday we learned that f of x is a fancy way of saying y equals. So if I rewrite this here, again, my beginning point is the 6. This is my y-intercept. And then the number in front of x, this is my slope. And this is going to tell me how I'm going to move from that beginning point. This is my rise and my run. Okay, so from that point, if it's a negative slope, I like to go down and then always to the right. You could, when it's a negative number, you could go up and left. Just make sure one of your rise and run, one of those movements is negative. So let's try and graph this one. I'm going to put my y-intercept or my beginning point on the y-axis at positive 6. And then from that positive 6, I'm going to move the slope. I'm going to go down 2, 1, 2, and to the right 1. I'll connect the points and I can graph my line. If you want a more specific line, you can keep repeating this rise and run and keep going. Down 2 over 1, down 2 over 1, and get more than just 2 points. Once you get your 2 points on the line or more than 2 points, connect the points and graph your line. All right, whenever you see the function notation equaling a number or y equals a number, this is always going to produce a horizontal line. So I highly recommend that you memorize that you see y equals a number, the graph is going to be a horizontal line. One way that maybe you can think about it is when you see the y, you can say that whatever number y equals, that's where my line is going through the y-axis at that number. So remember, if you did a little chart here, y always equals -3, and then it wouldn't matter what you put in for x. So the graph of y equals a number is always horizontal. Okay. So again, when it's y equals a number, the graph is going to be a horizontal line. We're going to also talk about, towards the end of this, about the slope of a horizontal line. The slope of a horizontal line, the slope is always 0. But we'll do that coming up. But again, remember when it's y equals a number, the graph of the line is always horizontal. Let's look at a vertical line. So whenever you're given a function or an equation and it's x equals a number, this is going to result in a vertical line. So it's touching the x-axis at -3. So it would be a vertical line through -3. Again, if you did a chart, x always equals -3 here. 1, 2, 3. This would not be a function. This would fail that vertical line test. So vertical lines are not functions. Next, we're going to have when you're given a point, which isn't the y-intercept, and the slope. It's still the same thing. The only difference is when I put my beginning point, it's just going to be this order pair. And then from there, I'm going to use my slope, and I'm going to go down 5 units and to the right 3. Now, if you'd rather go up and left, the movement left would indicate the negative. So that's what I showed here. And I showed you the directions that I'm moving. Either way, just realize that when your slope is negative, after you connect your points, the line should be falling from left to right. When it's a positive slope, so this would be a negative slope, when it rises from left to right, that would be the graph of a positive slope. So let's graph the ordered pair, -1, +5. Put my first point right there. And from that point, I'm going to move my rise and run. So my slope is rise over run. So I'm going to go down 5 units. So 1, 2, 3, 4, 5. And then run to the right, 1, 2, 3. Put my point right there. I can now connect the 2 points I just graphed. And there is my line. All right, let's find intercepts. Now, if I give you a picture of a graph, when I ask you to find the x and the y-intercept, you're just looking to see where does the graph cross the x or the y-axis. So, for example here, the pink line, you can see that the y-intercept, the y-intercept is right here at, all right, so the pink line is hitting the y-axis or my y-intercept. You're going to tell me it's hitting at the number 1, and you're going to write it as an ordered pair, so it's 0, 1. The pink line is hitting the x-axis, or the x-intercept, and it's hitting it at the number 2, so 2, 0. The green line is touching the x-axis, or my x-intercept, at -3, 0. And my y-intercept, it's touching the y-axis at 4, so 0, 4. Intercepts are going to end up being really important to us. So in order to find it from an equation or a function, we're going to plug in zeros. Notice all of my ordered pairs. The y-intercepts, the second coordinate or the second part of the ordered pair, the y value is always the number, but in the y-intercept, the first number is a 0. In the x-intercept, the x has the number, but the y is the 0. So you plug in the opposite variable for 0 when you're trying to find that intercept. So now we're going to find intercepts from an equation. So again, what I had just said, when we want to find the x-intercept, we set y equal to 0. When we want to find a y-intercept, we set x equal to 0. I'm also going to show you a trick I call Coverup. But let's just do it officially by plugging in the zeros. So if I want, now this one is a little different. The x and the y-intercept are actually going to be the same on this one. However, that's not always the case. Sometimes you're going to get a different x and y-intercept, just like we saw in the previous slide. So for example, if I want to find the x-intercept, I'm going to set y equal to 0. So I'm taking my original equation. I'm going to take out the y, put in a 0, and now solve for x. So I get 4x equals 0, because this is gone now. Divide by 4, x equals 0. So the ordered pair for the x-intercept is 0, 0. To find the y-intercept, I'm going to set x equal to 0. So 4 times 0 minus 5y equals 0. Negative 5y equals 0. Divide, and then my y-intercept is also 0, 0. So here, if I were to graph this, chances are it's probably going through the origin like that, something to that effect. Just like we saw before, though, you might get a graph where, see how I have a different y-intercept and a different x. But sometimes the x and the y-intercept could be the same. Yes?
Can you graph a line just off your intercepts or no?
Yeah. Yes, you can. Now, if it's the same, then we have to pick another point. So in this case, I couldn't graph them. So that's another technique for graphing. You find the x-intercept, you find the y-intercept, put the points on those two axes, and then connect them. Now, when it's the same number, that's when you have to plug in a different number for x to get a second point. Does that make sense?
Yeah.
Or I could rearrange this into slope-intercept form. So let's say I wanted to graph this. So I already know I have 1 point. It's going to be 0, 0. So what I could do is take 4x minus 5y, move the x over, because I want to put it into y equals mx plus b. Negative 5y equals negative 4x. Divide y equals 4 over 5x. Notice the b, the y-intercept is 0, which I just found. But then from that 0, 0, I now can move up 1, 2, 3, 4, and then run 1, 2, 3, 4, 1, 2, 3, 4, 5. So then I could put another point here. So again, my rise and my run. So then I can connect the points. Thank you. All right, next slide. We are going to be plugging in 0 for x to get the y-intercept and 0 for y to get the other intercept. So let's plug it in. So to get the x-intercept, I am going to replace y with 0. So 3x minus 2 times 0 equals negative 8. 3x, because this is gone now, equals negative 8. Divide by 3, and x equals negative 8 over 3. As in order pair, you get what you got for x, and remember, we replaced y with 0. Now to find the y-intercept, I am going to set x equal to 0. So 3 times 0 minus 2y equals negative 8. Negative 2y equals negative 8. Divide. And my y-intercept is going to occur at the order pair 0, 4. Good? Now, just like you asked, let's say I wanted to graph this thing. I could go ahead and on my y-axis, 1, 2, 3, 4, put that point there. And then on my x-axis, negative 8 over 3 is like 2 2/3. So what I do is come over here, about 2 2/3 negative, and then connect the points. Good? So that's another technique you can use.
Is that easier or harder than?
It all depends on what you're given. You know, like if you're given the equation in standard form, if you're good at plugging in the zeros and getting the intercepts, that would be faster. If you're faster at, you know, moving the x to the other side and then dividing, however you want to do it.
Yeah.
Yes?
Did you give us a fraction to graph or no?
I don't know. Anything goes. Yes?
When you put them together, wouldn't it be negative 8 over 3, comma 4, or are you supposed to keep them separate?
You keep them separate. Okay? Because again, remember the coordinates of an intercept, they need a 0 in there. So the x-intercept needs the number, comma 0. The y-intercept needs a 0, comma number. So you don't put them together. Because then that would be a totally different ordered pair. Does that make sense? All right. So let's try. Here's my trick for Coverup. So what I do is, essentially, when we're plugging in 0, anything times 0 makes it go away. So if I want to find the y-intercept, I'm going to take my x and I'm going to make it disappear. Now I'm going to solve what's left. Divide by negative 4, and my y-intercept is negative 7 over 4, and as an ordered pair, 0, comma, negative 7 over 4. I'm going to do the same thing to get my x-intercept. So to get my x-intercept, I cover up the y term. And now I'm going to solve what's left. 2x equals 7, divide by 2, and x equals 7 over 2. As a coordinate, 7 over 2, comma 0. Yes?
Like, on our quiz and stuff, when it asks for the x or y intercept, are we supposed to write the whole coordinate or just y equals?
Write it as a coordinate.
So we would write 2 different coordinates?
Again, I'm going to do the cover up. So to find my y-intercept, cover up x, solve what remains. Y equals negative 1. So again, as a coordinate, 0, comma, negative 1. To find the x-intercept, cover up the y, solve what's left. Now, this only works when it's in standard form, okay? Because you need the x and the y term together in order for this cover-up trick to work. So it has to be the x and the y together on one side and then the constant on the other. So then this gives me x equals negative 3/4, 3/4, comma 0. Again, always plugging in the 0 for the opposite part of the coordinate of what you're looking for also gives you the intercept, if you prefer just to plug in the 0. All right, now we're going to talk about slope. So the slope formula is y2 minus y1 over x2 minus x1. This little triangle means delta. So the change in y divided by the change in x. So slope is also defined as rise over run. So common mistakes I see with students with slope, they think the x goes on top because the x is first in the order pair. You must put the y coordinate on top. So last year, one of my students said, oh, my middle school teacher taught me this trick. You're going on a picnic and you're having your picnic on the side of a mountain because the side of the mountain's going to be sloped a little bit. So what you're going to do on the side of the mountain is you're going to set up your picnic table. So you're going to use the x's to make the legs of your picnic table. And at your picnic, you're going to serve some yum yum juice. So you put some y's on top. So whatever little trick's going to help you remember that the y's go on top and the x's on the bottom. So then you would say y2 minus y1 minus, And he got more in depth with putting some olives on there, and that made the numbers, but just realize that the X's are on the bottom and the Y's are on the top. These little subscripts on the Y2, Y1 and X2, X1, those are labels, and they're going to come from your order pairs. So you can think of these as order pair number 1 and then order pair number 2. That's what these little subscripts represent. It doesn't matter which one you label as X1, Y1 and X2, Y2, you still get the same answer. Now at the beginning, we saw this vertical line. Now we have to figure out what the slope of this vertical line is. So we can actually do the problem. I can figure out what these two order pairs are. So this order pair is the order pair 2, 1, this one right here, and then this one's 2, 2. So let's do the slope formula, 2, 1. Now on the test, if you realize that the slope of a vertical line is undefined, you don't have to do this. So again, if we're going to label this as x1, y1, x2, y2, 2 minus 1 over 2 minus 2, as soon as you see a 0 in the bottom of your fraction, this is undefined. So this is why the graph of a vertical line, the slope is undefined. So again, if you need little tricks to help you memorize, when I see a line that goes up and down, I know that this is undefined. So I use the U, the N, and the D. Up and down is undefined. Yes? Yes. Horizontal lines have a slope of 0. And we're going to do that on the next slide. So when the 0's in the top, if you're doing the slope formula, if the 0's in the top of the fraction after you do the formula, then it's a slope of 0, and it's a horizontal line. But when the 0 is in the denominator, the slope of a vertical line is undefined. If you are given a graph, or if you see your x coordinates with the same number, that's also a clue that it's going to be undefined. When the y's are the same, that's when the slope will be 0. Just real quick, the graph or the equation for this graph, remember whenever it's a vertical line, it's always y equals, and then the number, it's x equals the number where it's crossing that x-axis. So this would be x equals 2. So when it's a vertical line, it's x equals whatever number it's crossing that x-axis at. Let's try the next one. Oh, let me go back now. The horizontal line, remember this is the y equals and the number that it's crossing the y-axis at. If you want to go ahead and create order pairs out of this order pair is 1, 1. This one is, looks like 1, 2, 3, 1. And we can go ahead and plug it into the formula. 1 minus 1, 3 minus 1, 0 over 2. This simplifies to 0. So you need to memorize that a horizontal line has a slope of 0. So vertical is undefined, horizontal is 0. If you end up doing the whole formula, maybe they don't give you a graph. Soon as you do the formula, if the 0 is in the top, then you know it simplifies to 0. And again, a clue, if your y's are the same, it's 0. If your x's are the same, it's undefined. Okay, so here are two order pairs. Now I just want to demonstrate that it doesn't matter if I label this one, let's rewrite them here. So if this I say is order pair number 1, my x1, y1, this one, x2, y2, let me rewrite them over here. I want to show you that it doesn't matter, you still get the same answer. So let's say switch it up and say the first one's my order pair number 2. So let's go ahead and do the slope formula. So if I do negative 3 minus 8 over 2 minus negative 4, be very careful with your negatives. This gives me negative 11 over positive 6. If I do it this way, and I say this one, I'm going to get 8 minus negative 3. What did I do here? Let me switch this. This should have been that way. Okay, so now 8 minus negative 3 over negative 4 minus 2. Keep change flip here. It becomes positive 11 over negative 6. So whenever there is one negative sign in this slope, this is really tells me that this is negative 11 over 6 slope. It's a negative slope. If when you do the slope formula, if the numerator and the denominator have a negative sign, a negative divided by a negative is a positive. So if I would have ended up with this, then this would have simplified to a positive slope. So just remember, after you do the formula, if you end up with a negative in the numerator and the denominator, divide it and it becomes positive. Let's try the next one. Again, if you look at this and realize, wait a minute, my x's are the same, this is going to create an undefined slope. But let's go ahead and do the problem. If I do negative 4 minus 7 over 2 minus 2, negative 11 over 0, 0's in the denominator, so it's undefined. So when I did it here, I was just showing you that it didn't matter how you did it. You still got the same answer either way. So if the negative's in the top or the bottom, it doesn't matter. Just stay consistent. Good? All right, so now we're going to find the slope from an equation. If your equation is solved for y, so if it's in y equals mx plus b form, the slope is the number that's in front of x. So in this example, number 3, what is the slope of that line? Beautiful. What's the y-intercept? Negative 3. Good. Now the next one, we got to fix this one. We need to solve for y. Right now it's in standard form. This is good form if we wanted to find intercepts, because I could do my cover-up trick. But if I want to find the slope, I need to rearrange it. So I'm going to subtract the 2x. It's gone from here. Negative 2x plus 5. And now divide all three pieces by negative 3. Yes. So then here, really all I needed to do was figure out what the slope is. But let's go ahead and finish this off. Notice negative divided by negative makes this become positive 2/3. And then I'm just going to leave my y-intercept as an improper fraction. If I were graphing this, I would probably make that y-intercept into either a decimal or a mixed number, just so I could get an idea of where I needed to place it. But in this problem, I just wanted to find the slope. And again, the slope is what ends up in front of x. So the slope here is 2/3. Next one, again, I've already got y isolated, so all I have to do is divide by negative 2. So y is equal to, and again, negative divided by negative, so this will become positive 3 over 2, and then minus 7 over 2. And again, the slope is what's in front of x, so the slope of this line is 3 over 2. And again, after you plot your y-intercept, if you wanted to graph it, you'd graph negative 3.5. From that negative 3.5 on the y-axis, rise 3, run 2. Okay, so your work for this section is 7 through 23 odd, then jump down to 35 through 41, and then 53 through 57. This is what's on your quiz in addition to the 2-2. Quiz is on Tuesday. Now we are going to cover a little bit more of these linear functions and talk about parallel and perpendicular on Monday, and then we'll review. And then you take your quiz Tuesday. That's it.